Hi, this podcast is for CNT140. We're looking at Chapter 17 on troubleshooting LAN wiring. The things we're going to look at is common failures and wire faults, solutions for them, and some troubleshooting approaches. Alright, introduction. First thing we need to remember, there's a couple things they remind us here in the chapter. We've spent considerable time this semester in installing a reliable cable system, and the concept is if something goes wrong, it really shouldn't be the fault of our cabling. Now, the reality is failures do happen even with the cabling system. So, we want to be able to diagnose those and know how to repair them, relatively quickly. So that's the point of this chapter. And yeah, the LAN wiring system is subject to periodic failure, so we do need to be able to repair them. Now, I'm going to remind you, this is what we have installed this semester. We've pulled our horizontal cabling, we terminated the outlet jack, we terminated the patch panel, then we made patch cables to go in each end. And here's the thing we need to keep in mind. The stuff we're troubleshooting in this chapter and, with our LAN cabling is all under the assumption that everything is wired straight through. The whole system is wired straight through. So all of our meters are assuming everything's straight through. Anything out of that, anything out of the ordinary other than straight through, it's going to report as some kind of failure. So as long as we keep in our head that this stuff is, these meters are designed for testing straight through wiring, anything out of straight through wiring will show up as a fault. As long as we keep that in our head, we should be in good shape. We also need to remember our color codes: 568A color code, 568B color code. We did a lot of B color code in our lab this semester, so most things we had focused on B, but I need to remember them because that's going to help with identifying a problem fault or a fault, and then knowing how to repair that, or I recognize that it's wrong because the pinout is wrong, kind of thing. Here's what we also need to remember as we've been testing with our continuity tester, this little guy in our toolkit. A complete working cable run shows up as a pass. All four wires are wired straight through, pass, and I see, all four pairs lit up here with pass, and I see all four pairs on the remote end lit up. That is normal. My wire map, if I did a wire map on the cable run, shows all four wires or all four wire pairs straight through, no crosses, anything like that. Again, all of this is normal, straight through wiring, straight through, everything is normal. That is our normal. We are now going to be looking at the faults and what those are. The book says our cable link failures can really be divided into two different types: basic cable and performance based. Yes, and our basic cable function, I should say the meters we're going to use are for the basic cable function, meters like our continuity tester and a wire mapper. These are able to identify any of the basic cable functions, split, cross pairs, reverse pairs, break, short, open, those kind of things. These meters can easily identify because these are basic cable testing meters. Anything performance related, we do need our cable certification meter, the ideal meter or the fluke certification meter that we talked about. These are going to be able to identify problems with impedance, near and crosstalk, attenuation length, that kind of thing. So when they talk about breaking into two categories, basic and performance, our basic problems can be diagnosed with these meters, and our performance problems can be diagnosed with these meters. Okay, so let's start in with one of our first problems, a wire break. Very, common wiring failure, broken wire, reported as an open on the tester. The circuit is open. In this case, some wire testers actually indicate the whole wire pair is bad. Is the wires always broken? Not necessarily. It could just be that it was not terminated correctly at the patch panel, not terminated correctly at the outlet jack, but it could actually be a broken wire. Maybe I used the punch down tool backward and I cut the wire off before the termination point. So my normal wiring, straight through wiring, looks like this. A wire break map might look like this, showing the one wire is broken, but it might actually show that the pair here is faulty for some reason. On my continuity tester, I would test, when I first turn it on and run a test, it'll show fail. It'll show my remote end, one of the wires is out. I go through and do the fault check using the fault check on the right, and I go through each pair. When I get to the faulty pair, it'll say that this pair is open. So this is giving me a clue. The remote end is giving me a clue when I go through the fault check. This is passed, this is passed, this is open, this is passed. This is telling me what wire pair is open. Then I would be looking for the 4 or 5 wire. That's kind of in my middle. That's usually my blue wire pair. I would be looking for the blue wire pair not wired correctly at the outlet jack or the patch panel kind of thing. And then again, here's my wire map. The wire map that I would be getting with that looks something like that, where it's showing that that wire is open. So I'd be looking for the fault in the blue wire, the wire pair, if you will. If only one wire pair is showing as open, check the termination port connection. In my patch panel, maybe re-terminate, that sort of thing. Look at my terminations. I'm doing a visual check on all of this. I can actually find a lot doing visual checks. And my repair for this again is if it's broken at the end, I can literally pull the wires out of the patch panel, trim them off, re-terminate. I can maybe cut my outlet jack off, put a new outlet jack on, re-terminate. But if it's broken in the middle, my only solution for my copper twisted pair is literally replace the cable run. That's my only solution for a wire break. I'm not going to solder any wires together or anything like that. For a wire short is an unplanned path for electricity to flow. It's not usually caused by bad terminations, but it can be. It can be. I've had this happen. What's often caused is the wire's pinched. Sometimes actually a screw has gone through it. If I've installed on the wall, a drywall screw has gone through and maybe cut the wire, something of that effect, and the screw itself is causing a short. That can happen. Sometimes it actually is pinched, pulled over a sharp metal, maybe the metal suspended ceiling grid work. You pull it sharp over the edge and it cuts it, and the grid work is actually shorting the two wires together. That can happen. So how am I going to find this? Well, I can use, again, my basic meters to find that, and I can even use my wire mapper or my TDR to give me a ballpark of where that problem is. So let's take a look. Normal wire map, here we go. A wire short is usually going to show something of the effect of what wire pairs are being shorted. Sometimes you'll see an S, sometimes you'll see a bar here, and a lot of times they'll even give you some indication as to where. And that indication gives you an idea of where to begin your troubleshooting. If it's 2 feet away from you, it's somewhere in your, where you're working, whether it be the outlet jack end or the patch panel end. If it's 2 feet away, you're looking in that area for the problem. My continuity checker, that's not going to give you distance, but it will give you an idea of what wire pair. Again, my first test, it shows as a fail. I go through the individual wire pairs with the fault check. It's showing me that 1, 2 has been shorted. So in this case, I'd be looking at, the orange wire pair, if I'm dealing with a B color code, because that's pin 1, 2. So I'd be looking at that wire pair. I have had it where I did my terminations in my outlet jack a little sloppy, and when I put them in, 2 nicks on the wire, you cut the insulation off with the wire stripper. I've had 2 wires be nicked, and when I jammed them in the outlet box, those 2 wires shorted out. So it can just be a sloppy termination. So it's not always easy to see, but I'm trying to find that wire pair, in this case the white orange, and see if there's an issue with that. If I do a wire map check on this guy, I know he's a little blurry here, but he's showing you that's the white orange pair, and over here is giving you an indication of where the distance is. Again, if it's only a few feet from the meter, it's on that end. If it's a couple hundred feet away, it's the other end of the cable run. Maybe, the patch panel end, if you will, the other end of the cable run. Repair on this, it does depend on the type. If I'm dealing with coax, I can kind of cut it apart, re-terminate kind of thing. I mentioned that just for home use. Fiber repair, I can actually fusion splice that out once I locate where the fault is. If it's twisted pair, 568C standard does not allow for any splices, so I really do need to replace the cable run. If it's in the middle of the cable run, I need to replace the cable run. If it's on the end, if it's near the outlet jack or near the patch panel, I can cut off the faulty section. You'll be cut that couple inches out or that foot out, and then re-terminate and get around the short. That's fine. But if it's in the middle, I pretty much need to replace it. Now, side note. If you're ever stuck in a position out in the field where you need to repair this run quickly. Sometimes it's the whole repair it 5 minutes ago. For a temporary fix, I can cut out that bad section and actually put an outlet jack and an RJ45 in there and plug it back together for just a temporary fix. This is going to cause crosstalk and other issues, but it's one of those, if I need it fixed 5 minutes ago for some emergency purpose, I could do that, and then after hours or on the weekend, you pull that cable run out and replace it. You know, the proper answer is replace it, but there's a little trick in your tool bag if you need that. Connector open. Connector open is, well, probably the easiest way of thinking is if you made a patch cable, sometimes when you make a patch cable, the little wires don't make it the whole way to the end of the connector. So when you go to terminate, those wires are not actually being terminated. They don't go far enough into the outlet jack. That can happen. So bad crimps, those kinds of things, wrong module end connectors, a visual check is going to see that. I'll hold my patch cable up with some light behind it and look for the wires to be too short. That can cause that. So with a connector open, when I plug it in my meter, this one will kind of drive you batty because you actually think your meter's not working. When I plug my continuity meter in and test it, I see it fails, and I look at the remote end and nothing comes up. I go through the wire pairs, and I literally see 1, 2 open, 3, 6 open, 4, 5 open, 7, 8 open. It's showing every wire pair open. There's your clue. Every wire pair open is telling you that you have a connector open. Check your terminations on each end. In this case, it's usually a patch cable kind of thing that's causing this. And here's my wire mapping tool. It's showing, hey, I got nothing. It could not get a signal through the cable, so it's showing all 4 pairs open. To do that, I got to find the suspect end. Again, my meter sometimes can help me tell me what end, but I need to look at my terminations on each end and re-terminate. Chances are I can just do one end. I can re-terminate one end. All right, I'm going to pause there. When I come back, we're going to talk wrong pinouts.